Okay, I'm going to start off by mentioning a few things about memory, because it's going to be very useful for a number of things that we're going to go through this year. It's very important that you try to grasp these concepts because, like I said, when I was talking about things yesterday, when I introduced the course, that if you understand how things work in relation to memory, the majority of the structures, advanced structures that you're going to learn, that if you take computer science beyond grade 12 here and take it at university or college, are going to help you to understand those things. Okay? So now I'm not going to go into extreme detail because many of these kind of concepts you're going to go into detail with them later on, and it's not completely part of this course. But we all know when we deal with memory, so we have our RAM. Use this. Let me, if I could sync this up a little bit better. Hopefully that's a little, there, that's a little bit better. So we have our RAM over here, our memory. Whenever we run a program, you're going to have to interact with the memory, right? Every time we store some data in a variable, somehow it has to get stored inside it, in RAM, somewhere or another, right? Depending on the type of programming language you have, now we're dealing with a high-level programming language, like something like C#, Visual Basic, Java included. Those are higher-level languages. So they automate a number of processes for us. Now, for those of you that are going to go on into computer science and study it further, you're probably going to get in touch with languages such as assembly language, maybe. But most likely you'll learn C at one point, C and C++. In those languages like C and C++, you're going to manage memory more manually than you do when we use a language such as C# or Java. Okay? Now, there's a lot of risks when you're using a language like C and C++, because if you don't programmatically release the memory, you get what are called memory leaks. So that when your program ends, it's still holding on to memory. Right? And then you run the program again, and you close it, and then it's holding on to more memory. Over time, while a person's computer is on, if you keep running certain aspects of the program, it might keep on grabbing memory and not releasing it. And guess what happens in your RAM? And what happens to your computer? So what happens if your RAM starts getting all used up, right? If you start swapping with, not with, no, you're getting mixed up with CPU. It swaps to something else. You're thinking of CPU swapping between programs. So, sorry. It's going to start swapping. It's going to try and use, it's got to get memory from somewhere to store data. It's going to probably start using your hard drive, which is way slower, right? And then things are going to get really, really slow. So, pretty much right there, right? So then it gets really, really slow, and then you got to reboot your computer. But then when you reboot your computer, you'll notice that, hey, all my memory's low again. And then you might start to know, every time I run this program, I see my computer seems to get slower and slower and slower. So the person that wrote that program probably didn't release the memory. Now, that used to be more prevalent in programming maybe 10 years ago because most people use C, C++. There wasn't as many higher level programming languages out there. You probably would go, yeah, you go on task number probably out as a memory. So if a process gets kind of locked, it's kind of running in the background, that's one thing, so you can delete that too. And then that might tie in with memory. But also, if you shut the program down, you might see in the memory that a program is running. Yeah, so you might want to do from there. So yeah, it should help. Yeah. So you can do that, and that might cure it. But I mean, you don't want to write programs that do that. That's bad, right? Because that's not very. So one of the main problems is that people don't really understand how things work with memory. So when a program such as C# starts, and let's say you create, you go into the main method and you start putting variables and things in there, what it'll automatically do is it will allocate a little chunk of memory, and it's called the stack. Okay? So you can kind of think of it like that. Now, it's probably way more technical than this. I'm not going to go into it. Sometimes the CPU allocates some stack memory too, and things like that. But most of the time, most languages, and it might depend on the type of language you're using, but for the most part, a little chunk of RAM will be allocated to the stack. Okay, so it's a little chunk of memory. The rest we can refer to as called the heap. Okay. Whenever you start up a program, it's just going to start putting things on the stack. Now, the way a stack works is it's kind of like first in, last out. I got that right. First in, last out. So that means when I put a variable, let's say I have a method, my main method starts, it's going to put main on here. So that's the first thing in. So main will kind of be put on the stack. And it'll be assigned a location in memory, right? So you can think of every location in memory. So basically, in most computer systems, you can think of it as every byte that's there will have an address to it, right? It has a number associated to that location in memory. So you could think that, and same thing for the heap, right? So you're going to have some sort of address here. And all it is an integer data. Number value. So like 0, 0, 1, 1, 1, 1, 1, 2, 2, whatever. It'll just be a number. Okay? And they'll all be numbered. So when main runs, because it's going to have probably a return type, it'll pop it on the stack. And then it's going to look, maybe you started creating a bunch of variables that are inside there. Okay? We'll just do the types of variables that we did most of that, let's say primitive data types. Right? So if I had main over here, and then inside main, I had, I created an int called x, set it equal to 35, and then I had int y equals 20, okay, and then I did int z equals x times y, okay, and then I returned it, return z. Okay, I guess this would be a problem. Okay, so something like that, right? I didn't put all the bracketing and everything in there. Okay, so as soon as this main it's going to give it, it's going to pop it on the stack. It's going to have a little address associated to it, like a number. Okay, int x equals 35. It also is going to put the 35 in there. But the x will get popped on the stack because every time you put it in, the stack is going to go on top of each other, right? Then it's going to put the y on here. It's going to put the z on there. Okay, and then just that's what a stack is, right? You have stack papers, put things on top, right? And all of these things, and anything that you add in here, all variables, whatever. We're thinking just primitive data types right now. They're all going to go on that stack. Okay, and methods will go on there too, because they have a location memory. Okay, because they have to return things. Even if it's void, it'll still give it a location memory. If I want to access x, it's very, very quick. The stack is very, very fast. It's very, very efficient because it has all the primitive data types and stores them on there. It'll know where to go get it, and it gets it really, really extremely fast. Okay, and it'll know where to access it from. So when I call z, it'll access the x, the y, and then it'll do the calculation. Okay, and then that's and then it'll be able to access. And each one of these has a number on here, right? So there'll be some sort of number associated. So it can access those things very, very quickly. Okay. Makes sense so far? There's more to the stack than this, which we're going to learn when we do recursion. Because when the method ends, what happens is these get popped off. They just they become popping off, and then it just gets released from memory. So when the memory finishes.
We ask that grade 9 students come down, helping by the teachers, and we ask the teachers please sit with your class. Again, just grade 9. Would you please come down to the assembly, and we'll start our recording.
Break this down real quick. Fast. Okay. So when this method gets over here and it's going to finish and we do a return, it'll start releasing all this stuff from memory, and then the main will send back what the value of z is. Okay. But we're going to look at that part of it when we get to recursion and how it does that. Okay, so for right now, I just want to focus mostly on addresses. So primitive data types and method names, and you don't even have to worry about that, methods and stuff like that. But think of primitive data types, all get stored on the stack. It's very, very quick access to memory. Whenever you need to reference it inside that method, it's going to access it. If I have another method that's being called right after, by the time this thing finishes, all this stuff is automatically released from memory. It does it automatically. You don't have to worry about when you program. We don't put any code in there to say release it from memory, right? Once the method's done, it gets gone. Everything inside that method, gone. Okay? For primitive data types. Make sense? Okay? If I do something like this inside my code, if I do something like this, int, let's say a equals x, because these are primitive data types, what it'll automatically do is when it puts a inside the stack, it makes a copy. If it's a primitive data type, it'll make a copy of whatever the value of x is. In this case, it's what? 35. So inside the stack, a is going to go inside here, running out of room, and it's going to have 35. Okay? And it's a complete copy of it. Okay? Primitive data types, that's how it works. Okay? Now, what if I create an array? Okay? Now, what happens if I create an array? Let's say its size, it's an integer array. Okay, this is a little bit more of an advanced structure. The array, the data that's going to be stored in the array will not get put on the stack. Okay, it's not going to put on. It's more of a complex structure, and then if it were to be put on the stack, then it would make the stack slower too. Right? So what it gets put on is the heap. It's on the rest of the basically memory that's available to the program. So this will get stored somewhere over here. Okay? And again, the heap will anywhere in memory where you're going to start to allocate the information. This it also has addresses on it, just like it does for the stack. So basically every bit, whatever that's, every byte that's there will have an address allocated to it. So this array, this variable array, is really going to end up having its memory stored on the heap. Now, I'm a little rusty right now. My brain's not working right, but I'm pretty sure, we're going to have to look this up though. Okay? I'm pretty sure what's going to happen is the variable array gets put on the stack, but on the stack what it has is the actual address. That's all it will store on the stack. It might do that in some languages, it might not. We got to check that out. Because I can't remember 100% off the top of my head. Okay? So we want to look that up. So there's a possibility that this, but I don't think it does. Okay, I can't remember for some reason. I think maybe it does. I might be getting mixed up with some other languages that I've worked with. So, but think of it as whenever I want to access this array, what I'm really doing is I'm pointing to, that's an important word, I'm pointing to a location of memory. Okay? So what this, and I'm pointing to a location of memory, but it's not on the stack, it's on the heap now. Okay, so what this variable really is a pointer to a location in memory. Okay, so to a location in memory. So if my values in this array, so let's say my array is, let's say I have an array, I have 3 values in there. It's 7, 9, and 4. So it's going to go over here. 7, 9, and 4, right? So when I say give me, and this is index 0, 1, and 2, right? So when I write in my code, let's say I want to get access to array 1, what is that really saying? What's that saying? It's saying, first of all, go to the heap to get it, because the stack can't contain those kinds of structures. Okay, go to the heap, which is a little bit slower to access. Go to the memory location of array. Go to that memory location or the address location. Goes right over here. It's going to point to the beginning, right over here, right? Because it's going to get that memory. It's going to get that memory location, that address location of it. Go to the beginning, and it's going to say, jump over one. Well, what is it? It's an int. So int store how many bytes? How many bytes is an int store? You guys remember? Girls? When I say guys, I mean you too. It's a bad habit. 4. It's 4 bytes. So an int has 4 bytes. So it's going to say, jump over one 4-byte chunk, and then read the next 4 bytes to get the information. So it's going to go over here, because array, this variable itself, array, actually contains the address. So go there. So it goes there. It's now sitting there, and it's going to say, jump over one chunk of, well, how many, depends on how many bytes the data type that array is containing. Well, this data type for this array is an int, so jump over one set of 4 bytes. So it's going to jump over those 4 bytes, and then read the next 4. And then guess what? We read the 9. And this will return to me the value 9 inside there. So that's how it more or less does it. At a little bit more detail level than we talked about last year. Okay? Make sense so far? It's not too bad. I think the second semester class I did this a little bit more detail. The first semester class I don't think we had as much time. So depends where I had you. You might understand this a little bit more. But I don't want to go on if you're confused. Does that make sense? Okay? There is a way, we're going to look it up. Well, I got to look it up again. There is a way we can get the value of, let's say we create an array and put the 3 values in, like 4, 9, and say, give me the value of array, like give me the value of the pointer, like right to that memory location. It'll actually return a number. There's a way of doing it. I have to look it back up. I haven't done it. I usually don't teach this, but I think your brother said you should teach them more about pointers. So I'm going to do it. If it will help out, then we do it. Okay, so you can thank brother. Look at that. I said, no, it's good stuff to know. I do touch on it, but not usually in as much detail. But it's important to understand pointers, I think. I've always wondered if that was something worth doing. So it's good. So you will see in languages such as C and C++, you get access to the actual memory. You'll create a variable, you make it a pointer, but it's an array, and then you can get access to the memory location, or you can get memory to the actual data that's inside it. Okay. When we store variables such as this is a primitive. These are primitive data types. They're also referred to as. These are variables by value. Okay? So it stores the value directly in memory. These structures such as array, or when we do classes, or when we create variables that are classes, things like that, that are of class types or whatever, these are variables by reference. That's kind of the term that's commonly used. Some languages might use different wording. That's the way I've always learned it. So when you have whenever we create anything with a new keyword, that's the key. Whenever you use that new keyword, guess where you're going? What memory location are you going to? This one or this one? Whenever you're using the new keyword tells me that I'm creating an object. Objects can't be stored on the stack, so it has to be over here, right? So whenever the new keyword is used, for anytime you create a variable or any type of structure, that's a sure sign to tell you that you're creating the values, you're storing everything on the heap. Okay? And the variable name is actually a pointer to that location in memory, and then depending on the type of structure it is, in this case we're having an array, it's just going to jump over memory locations. It might not be. It might be an object, such as a class. And then you're jumping memory locations to get access to the properties or the methods and things like that. Everything is going to have a memory location. Okay? So in languages such as C or C++, you will manually work this out. It's not as automatic as we use it in language such as C#. It does that for us. You never even knew about it, right? And you were able to do it. But in in C++ or C, you use languages like that. You better make sure you understand how these things work. Okay? So it's good that you understand it. Okay? For moving on to next year. Because of the language you're using, you're not going to see that direct kind of reference, but it does help for certain things, and it will help for something as I'm going to show you in a second. So these are variables by value. These are variables by reference. When I access the values inside, it's called dereferencing. Another little throw that terminology at you. That's to get value on the heap. Okay? Just a little bit of terminology. So when I have something such as an array and I access its value, let's say the second element or third element or whatever element, I'm actually dereferencing it by using the pointer to go to that memory location, skipping over whatever chunks of memory that I have to get whatever array value element that I'm looking at, and then I'm getting the value. Okay? You would actually program those kinds of things in. You have to know the difference when you're using those languages. Don't worry, we're not really going to get there. We're not going to do that explicitly, right? It's all implicit. It all works behind the background, except you have to know one particular thing. I'll move on to the next bit. I just want to make sure, is this kind of clear, or are you guys confused? Not too bad. So I have to think of, whenever I use a new keyword, I'm going to the heap. Okay? I'm going to the heap, and really that variable is pointing to a location in memory, and then it's going about doing whatever it needs to do to get the actual data somewhere after that point of location in memory. So, okay? Now this is going to tie into the very next important part. If I create another array, I call it int y. Okay. On the other page, what do we call it? We call it array x. Array, no, we call it. Okay, I'll do this. I'll do it like this. Let me just create two arrays. So if I call this one array equals new. Okay. And then I'll do call this one data equals array. This is where the concept of by reference and by value are going to be very, very important. Because you have to know what's going on in the background or you're going to mess this part up. Let's say I have a few lines after here and I set this to, what was it, 7, 9, and 4. So I didn't put the code in here, just assume that I did. Is that okay? Everyone understands that? So we would write we would write array 0 equals 7, array, I don't want to write all that code in here. Okay, so let's say I already did that. So we'll put a couple little circles here just to imply that I put code in there to initialize the array for those values. Okay. If I do int data equals array after that, what do you think is going to happen? Remember, everything's a pointer to a memory location. If it's a by value, it makes a copy of it. But what's going to happen is this. So this will be my heap. So array is going to point to a location of memory, and it's going to say 7, 9, and 4, right? If I create a new variable int data, and I just say equals array, it won't make a copy because it's saying take this array called data, which is really a pointer to a location in memory, and say make it equal to the same pointer that that array points to. So what's going to happen is data is going to point to the same location over here because you're saying it equals to this. You're saying data equals this, but this isn't the whole structure. It's really just the pointer to it. So now you have two variables that point to the actual same location in memory. Hold on. So now if I do this, data 2, right? 0, 1, 2, and then I say it equals 5, what's going to happen is it's going to go over here, and it's going to go to 0, 1, 2, and it's going to change it to 5. I'm going to overwrite it like this, because if I try to use the eraser, it's going to... So now, if I go and I print off, so now if I write some code to print array, we're going to get the results of 7, 9, and 5. It's going to display. Because those two things are exactly pointing to the same thing in memory. Okay. If I want this data to be an exact copy or a replicate or a replication of the array variable, right? Shouldn't use that word. This is the array, that's the array. If I want this to be an exact copy of that, I can't do this because we're dealing with pointers when I do that. So I have to, I'm not using the new keyword here, right? So it doesn't make a new structure in memory. Because new says create a new structure in memory, create it on the heap. So if I wanted to do a copy, if I want this to be a copy of this, I would have to do int data equals new int, and it would have to be the size. You'd have to put the size of array inside here, whatever that is. It's 3, right? So you'd have to. So you could do array.length in here. You could put the variable array.length in here. Then after here, you would have to say data 0 equals array 0. Because when I do this thing right here, this is the dereferencing part. This is the part that goes and gets the actual value. Okay? Because I put the variable name data in there, which is the array, with the actual index in there. That goes to that location in memory, gives me the value. Right? If I'm just, okay, and I'll get your question in a second. If I just use this word by itself, it's the location at the beginning here. If I do this, it gives me the actual value. So this part here gives me the value. This part here just gives me the kind of the reference. Oh, I spelled that wrong. Jeez. reference to the beginning or the location where that structure begins. Question?
So data and array are two different variables.
Say that again.
So data and array are two different variables, but they're the same thing.
In this particular case right here, before I do this, right? So over here, I have two variable names that are pointing to the same thing in memory. Doesn't matter which one I use, I'm going to do the same thing to this, the memory that it's containing. So it's pointing to the same thing. So I just created two variables that are the same thing, pointing to the same thing, but they're not separate. I've used one to change the values, the other one also gets changed, because they're both pointing to the same thing. So really, they're both the same thing. Okay? When I do this now, and data equals new, this now automatically goes and creates a new location in memory. Right? And then when I do data 0 equals array 0, it'll take this value 7 and then put it in here. When I do that, and then I'm going to put dot, 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 because I just do the other ones, the other two, and then 9 will get copied over, and then, okay, so we're using 5 now, because we're going to change that. If I use the original value, that's 4, right? Now, if I go and change anything in data, change any of those elements that are inside the array, it's completely separate. Because data points to its own structure in memory, and array points to its own section in memory. Okay? But when I do it this way, this is a huge problem with software that's out there because it creates huge amounts of bugs. I've worked with so many people, even people like graduating from like Waterloo and stuff, no joking, that would make that mistake. And we'd be looking for days and days to find out why there's a bug. And the bug would only creep in every once in a blue moon. Because it depends on how you're doing it. Depends on the case that would come up. So it works great, except maybe in one particular case. Right? So I remember when I first started working, I was trying to help figure out one of these bugs. And it was because of that. I ended up figuring it out, but it took me way longer. And then I remember years later, because I thought to look for that all the time. So that's what I would do. So anytime I get bugs, I look for these object references, and I would tell you 99 out of 100 times, that's what it would be. And then so people would be looking at this stuff for like weeks, trying to figure this stuff out. I look at it in 15 minutes, I tell you, you got a problem with your object. You look like a superstar, and it's just the most simple little thing. That would be like the last job I worked at. I remember doing that a few times. I got a problem with your object references over there. Come on, yes. You know, but very, very common problem. Okay, when you guys are going to learn advanced data structures, it could be probably second year university. Everything's going to deal with pointers. So you're going to learn these structures called linked lists, circular lists, and it all deals with pointers to structures. If you don't understand this, you're going to be so confused, And it's really not that hard. You might have to read it a couple times to kind of get it straight in your head, but you're kind of hearing it here, and then you're going to hear it, and the prof will explain. They're going to go in more detail than I am, and then you'll really understand it, and it should be a breeze. Well, at least you're not going to get stuck on, things that you should know, right? Other students might get stuck on those things because they don't have this understanding of what's going on the heap and how these kinds of structures are implemented. So, rule of thumb: whenever you see the new keyword, okay, you know that it's going on the heap, and it's pointing to that location on the heap. If it's a primitive data type, and you're creating a variable, and you're storing it out, it goes on the stack, and it's very, very quick access to store and retrieve data. Okay? It's a little slower going to the heap. Who knows where it is on your memory? It takes a little bit longer. It's not, and the way that memory is set up is not as efficient as the stack is. And again, your programming language sets up the stack. You don't. Okay? You might have control over that if you use a language like C or C++, but for us, we don't. Okay? when I'm done with this array, I should state, if you're using a language like C or C++, you have to deallocate the memory. So when your program's going to end, or if you create that array inside a method, and when the method completes, right? In a language like C, C++, you have to say deallocate memory, get rid of it. Okay? In C++, C sharp, what we use, if I create the array inside my method main, when main finishes, there's a thing called a garbage collector. Java uses it, the same terminology. C++ uses it, VB, whatever. The garbage collector, depends when it has some time, we'll go and deallocate. It's already marked to be deleted, but it might not delete it right away, but it'll eventually delete it. And then it'll clear that memory out. We're writing small programs, so it clears it out. So when we create a program and we create an object using the new keyword inside a method, when that method finishes, you could assume that it's going to be automatically removed from memory. But keep in the back of your mind, you're going on to study, and you're going to use computer science, other languages, you have to manually tell it to remove from memory, deallocate from memory. So a language like C. Okay? It's very important to know. I think you should know that moving forward. Okay? We looked at last year, we created a class. Remember when we had our form? We would create a form and we would put the array inside that form class, and then we could use it in any method. Okay. So once that form is done executing and shut down, and it's closed and completely killed, the garbage collector comes in and removes that array. While that form's alive, then that array is alive. If I have a form, and I have methods inside my form like a button, I create the array inside the button. It's created in the button now. When that button finishes running, then the garbage collector will remove it. Okay? So that's important to kind of know too. So if I have a class, and I create an array over here, whatever it is, okay? This is going to live, this array is going to live until, and this is a form of some sort, right? And I create it here inside the class. I can use it anywhere inside, any method inside there, because it's available anywhere. And also, it'll stay alive while this form is up. But if I have a class form, let's say I have a button click method, and then I create my my array inside here. Okay. Once that button gets clicked and it runs the code, the array is dead. The array goes away because I created it inside here, and then it'll be released. The garbage collector will release it. Here, it's global to the whole class. So once that form is running and it stays up on the screen, then that array is alive until that form's closed down. And that goes for anything. So even if I did int x over here, okay, this will stay alive on the stack. This will stay alive on the stack while the whole form's alive. Once the form is shut down, then the stack will clear it. And over here, when this button click method gets clicked, it puts that on the stack. Once the button click event or that method finishes running, then everything that's been put on the stack that was created inside there gets deleted from memory. Whether it's the stack or the heap, it won't matter. Okay. When we're dealing with this thing, it's called variable scope. Okay. We'll talk a little bit more about that actually next minute when we go into talking about talking about, we're going to get into more of classes and objects, a little more detail than last year. I tell you guys, when you guys are done here, you can probably work a lot of some of this stuff. So you'll know all the little ins and outs. You can work with a high level language and do some good work. So try to get good summer jobs and stuff. You can like go places and do things. Like, don't be afraid, right? To do that. So if you're going to go off to computer science or engineering, you go into computers, you'll have a good background, I think, to work with. And don't be afraid, even if the company says we need someone with Java. You know, C#, it's so close that you'll pick it up very, very quickly. And then, so don't be afraid. Just say, yeah, I'll do it. You just get a good book on Java and then just figure it out as you go along. Because it's very, very similar to concepts. Okay? That's a nice way to start off the year, right? Take it slow, don't worry. Seems like, oh crap. I told you it was a big jump from this year. You guys, I tell you, it's going to be easy for you next year. Trust me. Okay? Review this. Does it kind of make sense? What I want you to do, okay, is go, just create a little lab for yourself, little test program. I'm going to call them test programs now. Forget the word lab. Okay? I might still say lab, but little test program. And what I want you to do in this little test program, so let's say you create a little form, put a button on there. Okay? Inside this button, so for the click event of that button, create an array. So create array 1, and then just create, and then set its values. You can pick as many values you want, 3, 4, 5 values, whatever. Assign values to each element of the array. Make it as big as you want. Remember, you're just going to hard code it in, so you don't have to make. You can just make it 3 or 4 elements in length, and then just create another one, array 2, or whatever you want to call it, and then just set it equal to array 1. Okay? Like I showed on the page before here. Right? Like this scenario. Do this. Right? Do that. Change the value of array 1 or array 2. Go ahead, change the value in there, and then see for yourself that when you print out all the, and then just maybe display it in on your form or whatever, the values of array 1 and array 2. And then you'll notice that they're both the same. So if I change an element of array 1, and it'll change, when I access that from array 2, it'll be the same, and vice versa. Because these two are pointed to the same location of memory. Then, set these as, use the new keyword. So this one has a new keyword, this one doesn't. So then, try out if I do array 1 using the new keyword, array 2 using the new keyword. Don't use the, if you use new and new, I have to, and then I say array 2 equals array 1 after that, then you're going to start messing things up. Try to see what happens. Play around with it with the references, and then you'll see how it works. So I think that's a good way to start, is to look at, before we even get into really any new stuff, this is kind of a nice continuation from last year. Play around with the new keyword and no new keyword and setting them equal to each other, and then print out the values and see what happens. It'll verify what we talked about today. Okay, so give it a go.
Okay. Well, that's it. Yeah.
And we're just talking this way because most of these teachers will get at least 80% or 90% of the kids. And it's better than typing 1 or 2 than all 30 or whatever. So that's great.
But something was good. No, it's gonna optimize because every time you say something like that, it also adds credit, guys. Add credit.
Mr. Jacob.
Quite add
Mr. Ken.
make it up.
Does everyone understand what I want you to do? Okay. So test it out. See how that behaves. And then you can prove it to yourself. I didn't make this stuff up.
See, good job.